We don't know what sparked it, but in an instant our universe was given its violent start. They'd say our universe began with a Big Bang. This has made a lot of people angry and has been widely been considered as a bad move. Jokes aside, it's from that infinitely small and dense point that everything in the universe originates, which, for better or worse, gave us the chance to exist and enjoy the mystery it presents. Around 200 million years after the Big Bang, the universe had cooled just enough for the first stars to form. These stars were many times more massive than our own, far brighter, and didn't last for more than a few million years. They eventually burned themselves out and ended their lives in spectacular events we know as supernova. Others collapsed back into themselves to form black holes. From those first supernovae, the first nebulas formed. Nebulas are the great star factories of our universe. They are made up of interstellar dust, helium, hydrogen gas, and plasma. They form from the gravitational attraction between the molecules. As more molecules clump together, the pressure and heat grows, and you just add some electromagnetic radiation and a star is born. After a star is born, there is sometimes a lot of leftover debris. As material orbited the parent star, larger pieces would collide and attract more dust and debris, and through accretion gain mass. As their mass increased, the planetesimals sweep out past through the debris fields and grow ever larger. It is from this process that our Earth was formed. Earth in the beginning was not a place for life. Our early history contained many strikes from comets and asteroids. Due to the size of these collisions, our surface became molten, but over time it would cool and form a crust. Under the crust, it would remain molten and become the driver of tectonic activity. Volcanism would dominate the landscape for millions of years. The prevailing theory about how the moon was formed is that it was once on its way to becoming its own planet, but instead collided with Earth in a massive impact and was formed from the debris. This was beneficial for us because it slowed down our rotation due to tidal friction. As a result of that, though, we are slowly losing our only moon. The exact origin of life is hotly debated and a discussion for elsewhere. Prevailing theories suggest it started in Earth's oceans around 3 to 2 billion years ago with single-celled organisms. Although not an environment for our survival, it was a perfect place for them. Cyanobacteria is the most successful and the most important to our story. At the outset, volcanism formed the Earth's early atmosphere. Oxygen accounted for less than 1%. Enter cyanobacteria. It produces oxygen as a byproduct of its photosynthesis, and due to its large numbers, it is thought to have kicked off the rusting of Earth and the conversion of our atmosphere into a place for life as we know it to exist. Chemistry is very similar to the process of combining ingredients in cooking. It is a vital branch of science responsible for the study, structure, and interactions of matter and energy in the universe. There are 5 divisions of chemistry: analytical, physical, biochemical, organic, and inorganic. All these branches help us better understand ourselves and the world around us. Chemistry shows us the science of how, why, and what in the creation of the universe. It's a core central science because it connects all the other divisions together. It explains atoms, molecules, elements, intermolecular forces, and chemical reactions. Its most important division is the basis in which all other topics base their facts on one specializing in another division of science. The periodic table in chemistry lists all the elements on Earth, their properties, relationships, and electron configurations. These elements are arranged in periods, columns, and groups such as halogens, noble gases, metalloids, alkaline metals, alkaline earth metals, and transition metals. Through these elements, we learn about radioactivity, ionization energy, and the photoelectric effect that leads into atomic physics. Chemistry is deeply rooted in biology and anatomy as it explains who we are and how we came to be. It explains the formation of the universe and the Big Bang Theory, to also how human body organs function on a molecular level. Biochemistry explores the chemical processes in our metabolism, genetics, and medicine, and our DNA. Science is our detailed interpretations through mathematics, history, and technology that we use to understand the universe through careful observations and records. Physics is concerned with the basic principles and concepts that describe how the universe works. It deals with matter, motion, force, and energy as the most fundamental science and vital to our existence. Through our senses, we evaluate our observations through the scientific method to create laws and theories. The scientific method, after observing what is around us, we collect data and gather research, then formulate a hypothesis of what we believe and conduct experiments to test our educated guess. After analyzing the data, we then draw our conclusion and create theories and scientific law. Through these methods, we have created the notions of measurement, time, quantities, Newton's laws of motion, speed of light, quantum theory, and general relativity. Motion, displacement, scalar, vector, speed, velocity, acceleration, free fall, gravity, momentum, friction, mass, weight, torque, force, power, kinetic, and potential energy are subjects that contribute to physics. Physics is one of the oldest and biggest fields of science, as it is both theoretical and analytical fields that are both used to understand our universe. There are several divisions of physics, such as classical mechanics, thermodynamics, relativity, quantum mechanics, and electromagnetism. Physics is the division of science responsible for the laws that govern the universe. The first law of thermodynamics states that heat is a form of energy and mandates the conservation of energy. The second law in effect states that because the entropy of the universe always increases, perpetual motion is impossible. But if toast always lands buttered side down and cats always land on their feet, then if we strap buttered toast to a cat's back and drop it, it will be perpetual motion? It can be said that everything moves in a wave. Waves are what happens when energy is transmitted through a medium. The most immediate example is sound waves. As I speak, my vocal cords are manipulating air into waves that our ears receive at different lengths depending on speed and strength. Our brains use electric pulses to tell us what the sound is, what it means, and how we should act. Electromagnetism is a term that encompasses many forms. It can be about the strong force, weak force, gravitation, or the interaction between molecules. These interactions can be expressed in the form of aurora borealis, whose displays are the result of solar wind particles reacting with our magnetosphere. Fairly importantly, it's one of the forces that ensures we don't fall through the floor. Gravity and electromagnetism interplay throughout the universe to help us exist. However, they only account for a small fraction of what is out there when compared to dark energy. Through our pursuits in science, we have found ways to detect, categorize, and quantify all we can in order to discover our place and purpose in the universe. I just hope the answer isn't 42.